Assalamualaikum, chapter direct and inverse proportions. Topics we discussed are exercise 1C practice question 9. For reference, we are using exercise 1C of this book, so stay tuned.
Practice now question number 9a. 3 men can dig 2 identical trenches in 5 hours, assuming that all the men work at the same rate. How long will it take 5 men to dig 7 such trenches? Okay, so first thing in the question that we have to find out that how many variables and what are the variables in this question. Let's see, men, identical trenches and hours. These are 3 variables that are involved in this question. So I'm going to just write down the variable first. Men, trenches and hour, that is time. Okay, now according to the question, there are 3 men who can dig 2 identical trenches in 5 hours. Okay, so when 3 variables are involved in any question, we have to solve these types of question in 2 steps, in which in each step we must keep one variable constant. So this is step 1. Alright, and let's see which variable I am going to keep constant. Okay, let's read the question again. 5 men, how long will it take 5 men to dig 7 such trenches? So I'm going to keep the middle one constant, this trenches. I'm going to keep this variable constant, so that I will find out the value how much time 5 men will take to dig 2 trenches. I'm going to keep trenches constant. So how much time 5 men will take to dig 2 trenches, and when I will find out the value, the time that 5 men will take to dig 2 trenches, then I am going to keep, in the next step, I am going to keep the variable of the workman constant, and we'll see that how much these 5 men will take to dig 7 trenches. How long will 5 men take to dig 7 trenches? See, if less men are working on a trench, they will take more time to dig or less time to dig? Yes, if 3 men are working to dig 2 trenches, they will take more time to dig the trenches as compared to 5 men. 5 men will take less time to dig 2 trenches. So we have discussed before a relationship in which one variable is decreasing and the other is increasing. Such kind of relationship is called inverse proportion. And in inverse proportion, when 3 variables are known and one variable is unknown, we can apply a formula, that is x1 into y1 is equals to x2 into y2. So let 3 be x1 and 5 be y1 and 5 be x2, and our unknown value will be y2. y2 is our unknown value. So I'm going to cross multiply to find the value of y2. y2 is equals to x1 y1 upon x2, implies that y2 is equals to, I'm putting the value, 3 multiply by 5, okay, 5 and 5 cancel, and value of y2 is going to be 3. So we can say that 5 men can dig 2 trenches in less time, that is 3 hours. Okay, now the second step, in which we are going to find out how long will 5 men take to dig 7 such trench. So I am going to keep 5 men the constant, and we'll find out how long 5 men will take to dig 7 trenches. Now let's see, if somebody has to dig 1 trench, they will take more time or less time. Of course, if somebody has to dig a trench, they will take less time to dig a trench comparatively than 2 trenches, right? If somebody has to dig a trench, 1 trench, they will take, let's see, 2 hours. And similarly, that person has to dig 2 trenches, he will take time double. Alright, so more trenches, if somebody has to dig more trenches, the time will increase. If somebody has to dig less trenches, the time will decrease. 5 men has to dig 2 trenches. Will the time decrease or increase comparatively? Those 5 men has to dig 7 trenches. If they have to dig 2 trenches, they will take less time. And if they will have to dig more trenches, of course, these 5 men will take more time. So, more trenches, less trenches, less time, and more trenches means more time. So in this part of our solution, we can see that the 2 variables that we are considering are increasing simultaneously. That means if one variable is increasing, the other variable is increasing. If the number of the trenches are increasing, the time is increasing. If the number of the trenches are decreasing, the time is decreasing. So, what kind of relationship is this? Is this the inverse proportion relationship? No, because in inverse proportion relationship, one value increases, the other value decreases, right? This is inverse proportion. But if one value is increasing, its corresponding value is also increasing, this kind of relationship is not inverse proportion, it is the direct proportion relationship. So we can clearly see that this relationship that we are considering in the step 2 of our solution is direct proportion relationship. And when direct proportion relationship comes, what formula we are going to use? We are going to use the formula y1 upon x1 is equals to y2 upon x2. Here three variables are known and one variable is unknown. So let's just call, let 2 be x1, 3 be y1 and 7 be x2, and y2 is going to be our unknown value. This is the same method that we did in exercise 1a when three variables were unknown and one variable was known. These are simple direct proportion question now. So what is going to be the value of y2? y2, just cross multiplying to keep unknown value on one side and the known value on the other side of is equal to, so y1 into x2 upon x1. That means, let's put the value. Y1 is 3 multiply by 7 upon 2, and it's going to be 10.5 minutes. So we will say that 5 men can dig 7 trenches in 10.5 minutes. Question 9, practice question 9, part B. 7 identical taps can fill 3 identical tanks in 45 minutes. How long will it take 5 of the taps to fill one tank? Okay, so again 3 variables are involved over here. One is tap, the other one is identical tank and tanks, and the third one is hours. All right, so according to the question, let's make a data. Okay, this is the step 1. 7 identical taps can fill 3 identical tanks in 45 minutes. How long will it take 5 of the taps to fill one of the tank? So in the step number 1, where 3 variables are involved, we will keep one variable constant. So we have to find out 5 of the taps to fill one tank. Okay, now I'm going to keep the middle one tanks variable, this variable constant, the middle one constant, and deal with the other two. So 7 taps can fill 3 tanks in 45 minutes. How long will 5 taps will take to fill 3 tanks? Alright, let's see the relationship again. 7 taps together, 7 identical taps can fill the tank in more time or less time comparatively with the 5 tank. So of course these taps will take lesser time to fill the tank, right? So more taps will finish their job in less time, and less taps will finish their job in more time. This is inverse proportion relationship. We use this formula. X1 be 7, Y1 be 45, X2 be 5, and Y2 be the unknown value. Value of Y2 X1 into Y1 upon X2, which means putting the values 63 hours. So we can write it down over here very neatly, or 5 men will dig 3 identical tanks in 63 hours. Alright, now step number 5 men can dig 3 identical 5 men can 5 identical taps can fill 3 identical tanks in 63 minutes. How long will 5 taps take to fill 1 tank? So here I'm going to keep this variable constant and will deal with the other two, identical tank and hours. So let's see tanks. If there are more tanks, how long will 5 taps take to fill it? More tanks, more time. Less tanks, less time. So what kind of relationship is this? If there are more tanks to fill, definitely time will increase, and if there are less tanks to fill, definitely time will decrease. What kind of relationship is this? Yes, this is the relationship of direct proportionality. And what formula we use in direct proportionality? When 3 variables are known and 1 variable is unknown, y1 over x1 is equals to y2 upon x2. Now let's put the values. y1 is 63 and x2 is 1 upon 3. Oh, 3 ones are 3. 121. So our required time will be 21 minutes.
Thank you for watching. Subscribe for more updates.